Hey everyone, I just want to make a quick video to run through a couple of the problems I ran into and solutions that I've come up with to get the iClone's character live linking successfully with a metahuman in Unreal 5. I figure this might be something of interest to a lot of people who are just getting into Unreal 5, or just getting into iClone, interested in Aculips and the face solving alternatives out there. And I definitely ran into some trouble early on. I think using just the Metahuman kit that came over from iClone, from iClone, it was stretching out the head, or it wasn't transferring some of the data directly off the bat. But I imagine this is something that they're going to work on. I know that they put out the kit and it was working in 47. We've seen tutorials and demos work where it was working for other people. This is going to be a little more of a in the weeds sort of video where we're going to jump into the animation blueprint and the event graph of the animation blueprint Anim graph, and talk about how we can get these shapes actually mapping across onto our character a little more effectively on our own. It's very possible that iClone actually puts out an updated animation blueprint that does all of this for you, so you might not have to do this. But if you are impatient or you just need a solution now, I hope that this is going to be a useful walkthrough. So, a little bit of background. I'm not an animation blueprint expert by any means. Typically more of a effects, slider, shader, material person myself. However, this is something that is useful to know and to work with, so I wanted to kind of work my way through it and get my bearings a little bit. So prior to this, I had very, very little animation blueprint experience. I'm hoping that that is encouraging to other people trying to do this and maybe being concerned that, oh, I don't have too much animation blueprint experience. Don't worry about it. I'm going to try to walk through pretty much what everything does. Prior to this, I'd also used the Faceware blueprint to connect LiveLink with a Faceware plugin, the also trial for that. And that was working pretty well. They provide a kit similarly for the metahumans that has its own animation blueprint in it, and it comes with a pose asset, which is a library of all of the different shapes that are going to facilitate the transfer of the curve data from the LiveLink onto the metahuman itself. So they did a lot of the heavy lifting there, and I wanted to leverage that as much as possible and learn from those assets to create the animation blueprint that is going to help get Lewis's animation here as our demo iClone character onto Bort, our little dummy over here in Unreal. So let's start with going through a kind of a quick background of the animation blueprint from Faceware. And that's going to be this guy. We'll start in the event graph. There's not a whole lot going on here, however, this is the one I'm currently using. This is the original Faceware. Okay, so this is the Faceware animation blueprint here, and we can see that there is our event blueprint update animation event node. So this is our kind of like our event tick if you're familiar with regular blueprints. This is our constant stream of trigger. So our execution on a tick just constantly feeding data. And then from here, we're going to go into an evaluate LiveLink node. This, again, was all prepared by Faceware. So we're using this Faceware LiveLink node, or this FTI LiveLink role. This is its own specific data structure, and it wasn't working for me with the iClone character right off the bat. Maybe I needed to just retool it a little bit to make it work. I'm not sure if that's Faceware proprietary or if this comes, if that's from the Faceware plugin that I got access to that, or if it is a part of the default ARKit or Unreal LiveLink roles. But it wasn't working for me when I made my copy of this, so I do switch away from that, and I'll talk a little bit about how I had to modify things for that to work. But that gives us this data result we're breaking that data result apart using this node here, this break FTI animation blueprint data, and that is, if we hover over it, it's going to let us know this is breaking it out into its member fields, and they've got specifically the head position, rotation, and then this animation values data here. So if we think of this kind of like a JSON structure, it would be like, you know, your top label and then the next series of data under it. So you've got your like header, the FTI animation blueprint, and then we've got our animation curves, which is probably one big like block, and then your XYZ position, rotation, or position for the head and rotation for the head, XYZ. So we're not dealing with the position and rotation here, but we are passing from the animation values into these two remapping nodes here, functions. This one is actually effectively exactly the same as these ones. It's just dealing with the head rotation values and position values. And they put it behind a Boolean, so you can say, yes, I want the position rotation, I do want the head moving, or no, I don't want the head moving, I just want the face capture. So that's useful depending on what type of performance you're trying to capture. So in here, if we take a dive in here, so we know that this input, first of all, this has been added, so by default, your function, if you make a new function, would not have an input. You have to click on the little plus here to add a new one, and you want to set it to that FTI animation role. Again, this is what Faceware did, so not what we're going to do for iClone. It's going to be similar, but different. So there's an input here, so we're passing in our data from the LiveLink, and then we have, down here, we can actually see this is just kind of a preview. This isn't actually, there's no execution line on this. It's just so we can see everything. If we pull this wire off and I say break again here, oops, break FTI animation data here. There's the value, static frame, and blueprint data. We're using the value data here. So break value or break FTI animation value data. That's going to give me this guy here, and if we maximize it, we're going to see all of that. So these are all the curves that are referenced in that structure that the Faceware data is expecting, if you will. And then each of these you can toggle which pins you want visible. So what they've done is they've broken these out into sections. This is just a sequence node. It's just do this and then this and then this. It's doing everything in here effectively all together. It's in a sequence, but the order doesn't really matter so much. It just lets them break these out, these execution wires, so they can kind of visually organize this a little bit more. And then they've just isolated specific clusters in each one of these, so that this is the brow data, this is the eye data, this is the nose and the cheek, and they just made little, kind of more human readable clusters, so that if you have to make an adjustment or tweak something, it's not like looking at this giant list. You can go in and just focus on the area of the face that is giving you trouble, so that's also nice. Then they also have kind of a cool thing here. So we're reading in the value of the curve directly here, but it's going through this extra like get value set function. So what's this doing? This is remapping the curve. So let's say we're getting a 0 to 1 data that's coming through on the LiveLink, like any of these curves that we're seeing here. But we want to tweak maybe at the extremes, like the 0 to 0.2 or 0.2 to or 0.8 to 1 ranges. Maybe we want to like soften or taper off a little bit. What they've done is they've made a curve asset for each of these, and they've put in, in some of them they've left it just 0 to 1, and it's just a regular Bezier, kind of like soft in, soft out. But in some of these, they've also added pins so that between 0.2 and 0.8, it's actually going to read the values directly, and then maybe do a little bit of a taper towards the top and the bottom. But if you did find specific shapes were blending more harshly than others, it would allow you to have that additional control at any point in time. You could come in and just tweak that curve asset for that one shape and not have to go into some separate part of the blueprint to do that. It's just a standalone asset. And so those are all named to match the actual value that they're setting, so that they're kind of like 1 to 1. When I was making my clone, I didn't actually realize that that's what this was doing, so I stripped this out, but it is functionality that I would potentially want to add back in, because it is highly sensible to be able to tweak those things on the fly separately. So that would be nice, and I will probably add those back in. But otherwise, I know this looks like a lot, but all of these are pretty much the same. It's just setting these values. It's giving you that opportunity to remap them. Some of them are literally one-to-one like this, and they're not changing anything. So it's just something to keep in mind, that we're not just straight blending all of these, although in my sample we are, but it's still a much better result than not at all. So from here, let's take a dive into, first of all, let's go back to the event graph, and we can just look at the head motion corrective real quick. That's going to be this guy, and it's the same exact thing, it's just the head data in here. So that's all that's different about that. So let's close out the functions, and let's go and see what is happening in the Anim graph, how we're actually using all of this stuff in this logic, pulling the data from the LiveLink and pushing it through those remapping functions. Let's get into the meat of the animation blueprint here, the Anim graph. And if we look over here on the left, we've got our cache pose. So this is going to kind of be like our input state. Again, for those of us not super familiar with animation blueprints in games, you're going to have kind of like your default state, or what's being fed in, and then we're going to maybe tweak or make modifications on top of that. So this is, you can just right click and do a cache pose, and you'll get that reference there. Otherwise, they're using a copy pose from mesh in this case here, and it's copying the curves. It's kind of serving the same purpose, but they're storing this now in this body pose. So they're making a pose, or setting up a pose and making a series of, now with that node. But they're stashing these different little collections of the animations. So in this case, we're doing the brow. Down here, we're doing the eyes. And they're storing these in individual clusters. And then up here, this is kind of like the master input or master blend tree. We are taking the default body pose and we are adding in the brow, the eye, the jaw, the cheek, the mouth, the lips, the head corrective motion, and then that is what is ultimately going to be the output or the result of our animation blueprint, the solve of all of that LiveLink curve data. So what's going on at the beginning of each of these? So we've got these pose nodes, which are a little tricky. I'll talk about those in a second. And then we've got this Faceware pose asset. So that's another variable that has been added, created by Faceware. This is using a pose asset variable type, and a pose asset, for those who are unfamiliar, like I was a few days ago, are these guys here. And they're just a series of blend shapes. So like there's our little Spock eyebrow here, good different movements. Each one of these, it seems like a blend shape, but it could actually be a series. It could be multiple blend shapes, or if we look at our curve data on the right, it could be a series of different shapes mixed together to get this result. In some cases, it might just be one. In other cases, it might be more than one. It might be a couple of things that are kind of being mixed together to get you a specific shape or result. I think I saw like a 0.5 or a 0.6 in there. I scrolled a little too fast. Yeah, so this is a couple of shapes right here, 0.5, 0.5, 0.5, to make this mouth right shape. So these are actually, you can create these right in Unreal, and we can actually create all the blend shapes that we would want, all the Visiums that we would ever want in Unreal using the Metahuman control rig. As long as we could do that in Sequencer, dropping it in, add the control rig track, which it does for you automatically. And what you're doing is you're making a pose per frame, and then you can bake that as an animation sequence, or you could also just use the animation editor by default, or the animation sequence window here. If you are comfortable animating bones in here, you can grab your bones and do all this in here. I know it's kind of a lot with the Metahuman bones though, so it's probably a little easier to do in Sequencer. Maybe we'll cover that on a separate video. But what we've got here is each one of these frames is a different pose. And that is going to get turned into each of those curves or those sliders in the pose asset. If we go to create asset from this animation sequence, go create pose asset from current animation, or we can even say insert pose if we want to add it back into the line here. We can make an independent one and add it. So that's how, if we want to start adding in Vism shapes that we don't have currently, we can, which is fantastic. But in this case, we've already got the pose asset generated. These would come through as like frame 1, frame 2, or pose 1, pose 2, and then you can right click on these and say rename, or hit F2, it says is the shortcut for renaming everywhere in Unreal for what it's worth. You can hit F2 and change the name of each of these, and then these are going to be the names that we'll be referencing in the animation blueprint. Over here, when we're doing one of these poses, we're doing a pose by name. So this took me a minute to figure out, again, because I'm brand new to this, but these poses, these nodes aren't nodes that you can just like right click and get, even if you're using context sensitivity, which would be on by default, but if you turn it off, you still won't be able to find this node. If you pull a wire out and type pose, you're not going to get this node. You're going to get some other stuff here. So this is actually created by dragging a reference to your pose asset in, and then you're like, oh wait, Brett, this looks different. Well, so you got to right click on one of these and go to convert to pose by name. So that's going to make it a pose by name node. And then we have to expose these pins. In this case, we're exposing the pose asset, and we're exposing this pose weight. So this one's easy. You just right click on the pose asset, or left click on this drop down, expose this pin. So that'll give you that. And then similarly, I could drag that wire in here. It updates the little name there. But now to get the pose weight, we have to actually expose this as a pin, but it's still not letting you, it's giving you just this pose weight and a number. You could actually go down to this drop down and pick one of our referenced pose shapes, which these are all floats that have been added, variables that have been added in here. And they match the names of those poses in the pose asset for sake of aligning things more easily. Even though it can make it a little confusing, it'd be nice to maybe say like, oh, this is the actual pose that we're referencing, or this is the value driving the pose, like a strength maybe or something, just to denote that the variable's a little different than the actual weight that it's driving. But they're the same so that it's easy for people to try to match them. But that gives us the actual drop down here, so we can now plug something into this if we wanted to, or we could click on the drop down here to change it, which is nice. And again, if we plug that pose asset into there now, it's going to drive, it's going to use that weight to drive the curve. However, to pick the curve that it's actually driving, you still have to select this node and tell it what pose we want this to drive. So if we look at these, this is also set to a bind. So we would have to come in here and tell it what we want this to be. Either expose that as a pin, which is one way to do it, or we can just type in a name. Like in this case, we are looking for like the Faceware brow inner up, which is going to come from here. Or let's do this one, Faceware brow outer up left, or Spock pose. So I can right click on this. I could say rename. I could just copy that, and then in the animation blueprint, I could select this node, I could paste this here, and that is going to make sure that we are driving that thing specifically. And then if we had our apply additive, we're getting pretty close there. I'm just looking to see, these are all set to none, that's bind, these are all the same. So I think this might just be a compile thing. I'm not sure what the fast path deal is there, but so far that has not affected my ability to do anything here. So that's something, if you know what that is, please definitely let me know. But otherwise, if I have had to add any custom ones, I can copy this and paste it, or this should pretty much do the same sort of deal. So again, we're taking the pose asset, which contains our Unreal side list of shapes and curves, and we are breaking that down, driving it with our float value, which is being set by our remapper, which is pulling our live link data, storing it in that blueprint variable for us here, and then the Faceware one is using this curve to remap that value if they need to refine it or tweak it, and then stashing that before it is ultimately being used as the weight to drive how much of that shape should be active. They're blending all of those together into a single state here, and then blending all of those together to give us our resulting face here. Whew. All right, I know that's a lot. Maybe a good spot to pause and come back in like a minute. But it's important to understand how that worked, because all I did was make a copy of this blueprint and then tweak it a bit to use some of the default LiveLink roles, the default animation role. And I did strip out those remapping functions, so it will look a little more sparse. It's actually technically got a little less control. But I might come back and I might still try to add those in later. But otherwise, I am piggybacking off all of this work that Faceware has done for us. Thank you, Faceware. This is very handy. It's a great reference. And it's really gotten me really far in terms of getting this iClone LiveLink to work. So jumping back over here, now we are looking at my copy of the Faceware blueprint. This is effectively, I know I'm calling it Faceware clone, but you could think of this as being the animation blueprint for iClone to Metahuman at this point. A bespoke custom version that I made, not the one that comes from the Metahuman kit. They, again, might still put out their own, but this is the one that's working for me at the moment. So in here, I'm, again, still using the event blueprint update, and I'm doing an evaluate LiveLink frame from here. The subject name, so once I have an active LiveLink like I do right now, I've got my LiveLink enabled, I've got my iClone side projecting, so that is also enabled, so it's on in Unreal, on in iClone. Then that's going to actually let me know, okay, so I'm getting this name, this is actually coming through because of iClone, and I can select it from here, and it's going to put the name in right there. The role is the animation role, so this is kind of like the default, or one, you know, the shipped with Unreal roles for LiveLink data. This is going to be used if you're working with like Maya or something else, or Faceware. Well, they've got their own. But then otherwise, I've taken this. The resulting data is going to be a little bit different, so we don't need that extra node here to break this into its member components. We're going to be pulling straight from this data, but we'll do that inside the functions here. So I did go ahead and break out the head position rotation into its own function, and then the face stuff into its own function, mirroring again the Faceware structure, or starting with that. Like I copied the function even and started from that. But in here, you can see this looks a little different. Still using the sequence, but I don't need to do the breakout and all the adjustments with the pins like we were doing. Again, now we're looking at the Faceware one here, and that's how it was set up with this extra node here. In my copy here, we're just using a get curves node, and from there, this is a map. When you get the curves, you're getting your key, which is the name of the curve, and a value, a float value, which is the actual data that's coming through on the curve. And if we move this for a moment and we look at our LiveLink curve debug UI over here, we can see that that's exactly what we're looking at. The curve name, that's our key. Curve value, that is our float. And yeah, if you didn't know how maps work, that's a great example of a map. So with our find node here, we can tell it which key we want to find, and then it's going to give us an output of the value of that key, and we're going to set that using the same variables, again, that Faceware provided for us in their template. And yeah, I use that as the framework to come through. There were a couple instances where I did not find a curve coming through in my active LiveLink that sounded like or read like a really good match for some of these. So in those cases, I left them blank just so I could reference them. They're coming through as 0, so they won't impact my solve in any way or my resulting like shapes. But those are a couple maybe that didn't really match, that Faceware like had support for, that maybe iClone's face doesn't necessarily, or just doesn't break it out the same way. Some of these are going to be pretty close. The wording is a little different, but again, I'm really just like keeping this up in like one part of my screen and referencing, scrub my sample character to a different spot and see like, okay, well, he's getting this really good shape here. Well, which shape do I maybe not have like represented? Like maybe it's one of these, like the tight O or the ah sound or the tongue up. These are things maybe that Faceware doesn't have in their pose asset, so these might be ones I need to create or add. Or maybe there is an existing shape in the pose asset that seems like a better match for this, but maybe I'm not running like a wire into it, or maybe I don't have a driver for it in my animation blueprint. So maybe I want to find, what shape is being activated heavily in that moment, and then hook that up to a pose that I know is going to give me a similar result. So I've gone through and I've mapped some of these, and I'll kind of jump around on these, or I'll let the camera sit for a moment. So if you need to pause, reference some of these, you can. For the brow, we've got a few here. Again, I didn't do the brow inner up or inner down because I didn't really see a good match for those. If we jump over here, we've got the eyes. And these ones were all pretty much one-to-one, same sorts of shapes, maybe slightly different wording. So those are those. If we jump over here, we've got the cheek kind of like pinches and the nose sneer. Those were all pretty similar as well. Some of these have like letters in them. Again, that's just what the curve debugger says that they're called, so that's what I was using. Jaw move, L, R for left and right. Open, it was just called for the jaw open, so that's what I'm using there. Just making sure I'm not missing any. We've got our mouth, some more mouth shapes. Here are the mouth shapes. We've got up, down, left, right, smile left, frown left, smile right, frown right. So those are what those were called. And again, if you miss any of these here, look at your curve debugger UI and you will find these. That's exactly where I got them, and I'll scroll back through them there as well, so you can kind of see, and I'll let the LiveLink play so you can see how they're firing as well. So we've got the mouth ones here, stretch, right, left. Didn't see a good match for the narrow left, right. If I find those, I'll add them back in. So we've got upper, up, left, upper, up, right, etc. Going on down, lower, down, right, down here. And let me just make sure we've got the rest of these here. So we've got funnel, press, and pucker. These were the first ones that I saw when I was scrolling through the list, and I actually ended up using something else for press and pucker, and I think it was giving me a better result. So these two are getting set here. They are actually technically getting overwritten a little bit further down, which I'll show you. Making sure that I've covered those. Those were all the existing ones from iClone, so then these are the two I added. Just again, looking through the list, seeing what was firing when I was getting when the character was making like an O sound or like the F sound, kind of, or like even like the T, D, that like T, D, or the F types of sounds. And it seemed like I was getting this curve for the dental lip. It's like the teeth over the lip sort of shape. That was giving me a much better result. So ultimately, I'm now setting that to the press variable and using the tight O for the pucker. Again, pucker and press being the Faceware pose names for those shapes. I could also have gone and tried to make my own like tight O shape or my own like shape. And I might still go and try to do that before my trial runs out to see if I can get an even better result. But for now, these were the ones I'm using based on the Faceware poses that I had available to me. So jumping back over here, that's what's going on here. The head motion itself, these are actually just corrective shapes. So they're like little subtle like things in the neck, like as you turn, or as you make different like shapes, even if like kind of do like that, like kind of like swallow, you see all this stuff moving in my neck. these are kind of managing little tweaks and things in there. So these are not the actual head motion. I had to bring that back in separately. I'll talk about that when we get to it. So those are the two functions in the event graph. And again, I know it sounds like a lot, but I feel like it's a lot more simple ultimately than it seems. It's just a lot of line items. As long as you can kind of keep track of them and you can reference back to your pose asset and see like, okay, wait, am I trying to drive this one? Am I trying to drive that one? Then it can start to kind of click and make some sense. But let's look at the Anim graph here because I haven't done much. I'll come back over to the side, but before that even, the vast majority of these are exactly how they were from the Faceware Blueprint. The only ones I've tweaked or added down here, and I just copied these and pasted them, are a different pucker and press. So I'm using, these are the names of the variables in here, but they are also driving that specific pose from the pose asset. So I came in here and I was scrubbing through these and I was like, okay, well, that's pretty good for kind of like the type of sound. It doesn't give me the teeth, but it at least kind of gives me the horizontal like stretch. And the pucker for the O, that's what I'm using for that. So I wanted to make sure that those are being driven down here. So I added those. If I start making some more custom shapes, I'll probably continue to like stack them on down here. But the rest of that's all exactly as it was. And then over here, this is all exactly as it was. This bit here, I'll come back to in a moment, but it is a little more traditional animation blueprint. It is a modified bone, ultimately. I'm getting the LiveLink data, or LiveLink pose directly here. So that's giving me all the bone transforms for like the neck and everything. And I am blending that into the face animation here using the layer blend per bone. This node, when you create it, you have to set a couple of things. So I had to like click plus in here under the branch filters. Branch filter was the default method in here. But if I just do layer blend per bone in here, it'll be set up kind of like this. I just click on the plus for branch filter. Then in here you can set the name of the bone. So I actually experimented. I started with neck like 01, neck 02, and then ultimately up to the head bone, which is kind of like right at the base of the head. You can change this blend depth, which will try to kind of like blend it down into those other bones. So if you can change like how much it's getting blended in. You can also change these to be in mesh space for a couple of things. It's got a few other parameters, but ultimately I'm kind of just using the head is the only, I just put in the name of that bone. I'm leaving it at 0. And then it still wasn't perfect for Lewis. His head was getting stretched out a lot. So I'm not sure if it's just like how their rig was set up, if there's some sort of bone like positioning set up in there. But it was coming through and making Bort kind of go into like giraffe mode where his neck was like really stretched out. I think I might have a quick, this guy over here. That was what it was initially giving me. And he's actually using the animation blueprint that came from the Metahuman kit, coming from the Metahuman kit from iClone. It's probably in like a work in progress state or something. I imagine that they're still working on it. But it wasn't giving me any of the face stuff. So maybe I did something wrong. Maybe it's still kind of experimental with Unreal 5. If anyone has better success with that off the shelf, let me know. But that's pretty much why I went into this whole rabbit hole in the first place of trying to use the Faceware one to get a better result. So this is my work in progress guy over here. We'll focus back in on him. And let's go back to our animation blueprint. So because it was giving me such a stretch in there, I wanted to have this modified bone transform. Even with the layer blend per bone, isolating it to just the head, it did get rid of some of the stretch, but not all of it. And if I set this actually back to 0, you can see that's what I was getting, even at this point. So I just went ahead and I added this extra modify transform bone. So this is a transform or modify bone. It says transform on there. Same type of deal with this one. You actually have to set a couple of things in here to make this like work or do anything. You have to kind of configure the node. So you have to tell it what bone you want to modify. So I set it to head, and it says up there, you know, now in the top bone, set to head, bone, head. And then in here you also have to tell it specifically for like translation and rotation and scale what you want it to do, because by default it would be set to ignore, and it will set up a little warning when you plug things into here saying like, actually, we know you made this node, but it's not doing anything. So you have to tell your translation mode to actually add or replace, and then in what space you want it to do that. So what I've set it to here is I've set it to bone space. I want to use the bone like transform controller, and I want to completely reset or replace the value that's on it. So I was hoping that setting it to just 0 would center it out. Clearly that's not quite the case here. We're stretched out a little bit still. So I went ahead and I just right-clicked on my translation pin and I promoted that to a variable, just like this, promote to variable, just not for scale, for translation. And then on here I set my default value to about -6, and that brought me back to about the realm of reality for my head here, and that's pretty similar as well to this guy. Maybe a little shorter. I think -5.5 was still a little stretched out for me, so I'm going to stick to the -6 for now. But if it's a variable now, so it's in my class defaults, I can just access it from there, or I can select it here. I can click on the little eyeball to make it public. I can expose it to cinematics, and we can adjust this on the fly. I can access this through sequencer, and I could tweak it like on a per shot basis if I needed to, and that'd be really handy. So that is all of the stuff that's going on there. These were just some demo nodes. These were just some experiments. Again, trying to get my bearings. But this is all I've really done. I know it sounds like a lot, but you know, I think once you kind of have the understanding of what is happening here and what the Faceware structure of their blueprint is doing for us, going in and modifying it, and now even from here going in and creating additional shapes or poses and getting a better solve, should hopefully only be, you know, maybe like a day or two of kind of like tweaking and playing with everything. So from here, I'll go ahead and minimize this, and we can take a look at the magic. And let me go ahead and just mute my desktop audio, so hopefully that's not coming through in the video. But yeah, we're seeing kind of the whole transfer here, and it's pretty decent. Let me go ahead and maximize this. I'll just let it play for a minute. I'll turn the audio back on again one more time after this so you can hear the sounds as they're blending in. But it's a lot better than it was with where it had no face and just the stretched out head of our guy off to the side over there. Now we're getting the emotion, we're getting the eyes, we're getting the brow, we're getting the nose, and the metahuman shaders with all of their nice little blend shapes that accentuate the scrunches and the wrinkles of the brow and the eyes are taking it all that much further, and yeah, doing what they do best. Just to note, other people have called this out in tutorials in the past, but the whole LiveLink will really do a lot better the more you can do to optimize your viewports from one package to the other. So minimizing the timeline in iClone gets you a couple of frames back in here. So not having that there bumps us back up to about 60 FPS in here, which is fantastic. And then in Unreal, I got my scalability settings dropped down to high right now. So I'm still getting some of the kind of subsurface scattering and the lighting, which is nice. You could drop this down even lower if you go all the way down to low. We're probably sitting at a comfortable, we're easily at 60 FPS here, even breaking it a little bit here and there. So if I'm just doing a capture, like pure capture, or if I'm doing take recorder, then I'd probably want to go ahead and set this back to low. But just for the preview purposes for video, we're really, I'm still in the 40s here, so it's not terrible. But you will get that much more data, if you're in the low settings. So yeah, that's kind of all that I've got for now. I know this has already turned into kind of a long video. I'll see if I can cut it down a little bit in editing. But I posted some screenshots of the blueprint, some of these as images on the Reallusion Discord channel, which I just googled the Reallusion Discord. Reallusion's the company that created iClone. This is using iClone 7. iClone 8 came out just the other day. I have not tried iClone 8. I'm using the educational license for iClone 7 here. I'm using a free trial for the LiveLink. I was using a free trial for Faceware. So I have not gone all in just yet. I still might. I'm really, really kind of impressed with the results of Aculips here and the capabilities that it brings. I'll probably do another video just demonstrating recording my own voice and wiring that through onto here, because it's, now that this all works, it's a pretty straightforward process. And again, that's going to be an iClone 7 tutorial. It might be different in 8. I don't know about stability over there. I would recommend checking out the Discord and talking to the community a little bit and hearing about it there, or just grabbing the trial, giving it a shot. Because yeah, it's pretty cool, and I think it's a little stronger for the mouth in particular compared to Faceware. It's probably, you know, more on par with the iPhone ARKit sort of interpolation of the face, if not a little bit better than that, because they're specifically, you know, sculpted, edited, designed visemes for those mouth shapes, so you're really getting the shape of the mouth to match each of the sounds of each word. So I look forward to playing with it a little bit more. I think it's a cool system, and I hope that this is helpful for anyone else who's trying to get iClone LiveLink working with a metahuman character in Unreal. Definitely, if you have questions, you can find me over on that Reallusion Discord, or drop a comment, and I will do what I can to help you out. All right, thanks a lot. I hope this helps.